So I can't do any more with the capacitors right now. I'm waiting for parts to turn up. Until those turn up, I can't do any more. But the fan does need doing. So we're going to take the fan apart and see if the bearings can be done or something to try and make it quieter, because right now it's too damn noisy. You know, rumbling a little bit and stuff like that. So the bearings are probably shot. For God's sake, don't cut the wire. Okay. There's the fan. Yeah. If I undid that one, that whole housing might come off, actually. I was wanting to rubber mount this thing, but it's on these standoffs, which are built into this frame. So rubber mounting that isn't an option. I don't think. So rubber mounting would have made it a bit nicer, but yeah, I'm pretty sure that's the problem. Can I fix this? Yeah, even tipping it sideways is making it wobble. Yeah. Let's pull this label up, see if I can get underneath it. I'm hoping I can just replace bearings. It's a 115 volt fan. I might have some, but nothing this size, I don't think. I've got a selection of fans, but I don't know if I've got the right one. Okay, nothing that side to worry about. It's all on this side. I'm not quite sure how this is designed. I haven't seen this set up before. It looks almost like it clips in, but I'm not sure. So this plate here was indeed popped in, but actually maybe what I could have actually done is turned it. Now I kind of levered it out and did get it out, but now there's actually slots here, so maybe I should have turned it and then it would have just dropped out. Inside the centre here is a little rubber cap. Taking that off. You see it wants to move like this. I don't know where to go from here. That's an awful lot of play in there. I'm not sure that's right. There is a little clip in there actually. I can see a little clip. Tiny little clip. Yep. See it? Just there. So that is what's locking it in, but what's causing all this slop in here? Anyway, we'll get that clip out. That's very small. I don't know if I've got any pliers to do that. I'll have to see what I can do. So I've got that little clip off, and then it's just lifted straight off. And then the question is, why is there so much slop in this motor? I mean, it moves a lot. It seems like it's too much. So there's a fixed shaft, so we can forget that half. We don't do anything with that. Maybe give it a clean. And this half will have the bearings in it. It's got another, like a star washer in there. So I'm guessing I've got to get that out. And bearings in there. I do have bearings. Whether I've got ones which are the right size, I don't know yet. Just got to try and get this star washer out. Started moving. There we go. Star washer. Now what? I think this might push out. I honestly have no idea. That might push out now. Yep, there goes a washer. Another washer. It's got a nylon in between them, so it's two washers with a nylon in between. Is that as a brass bush? It might be. It might be a brass bush and nothing else. Let's see if I can push that. Can I push that? Yes, probably. So I'm just going to try gently pushing with this to see if that will slide, because I don't know if it's a brass bush or if it's bearings. Well, bronze bush. It might be bronze. Doesn't want to just slide. Could try going the other way. No, doesn't want to go. So that might not be repairable if that is what I think it is, which is a brass or bronze bushing. Let's try picking at this end a bit more. Here we go. Here's another washer. Pair of washers. Here's another one. Lots and lots of washers. Is it just like it needs more washers to take the slack out of it? Yeah, I think these are just bushes. There's two bushes. Just separate a little bit. Yeah, that's all it is. There's no bearings, just bushes. Yeah, repairing it doesn't look too hopeful. Shimming it and stuff might have been a waste of time, I don't know, but we'll see. But it's not rattling anymore. But I'm not sure it's right. I think it seems to be basically relying on this end cap here to push on a rubber bung to push onto the end of the shaft to try and create a thing of taking the slop out. But right now, that's sounding better. And I've lubricated it all, so I don't know. It's the best I can do right now. Maybe it's enough. Well, I'm going to try this. I've got the fan plugged in. We're going to see if it is noisy or not. So when I power this up, this should come on. I've got the switch already pushed in. So we'll find out if it's bad or not. There's nothing happening. That's not what I was expecting. Nothing. Unless somehow I damaged it when I took it apart. But I don't see how. I don't see how I could have damaged it by taking it apart. Let's check the resistance. Check the winding. Just in case. If I have damaged it, then I've got to get a new fan. That should be awesome, wouldn't it? 540 ohms. That seems to be fine. So, I think the fans are alright. Strange. Let's check for AC across the terminals. Maybe there's something wrong there. Don't slip. AC is there. So if there's AC there, I have to have broken the fan somehow. Well, that's a step backwards. I put the fan back together again. I took this little plastic washer back out again, and it's working again. Although it's only taking a little bit of play, it seems to be enough to upset it. You're just making it a little bit too tight. And the longer it's running for now, the noisier it's getting. I think I need to try and find a replacement fan. Right, parts have arrived. Well, mostly. I've got the capacitors I need. Now, these ones here are tricky because these axial caps, I was looking to buy the right ones. Well, originally I actually bought the wrong ones, so I got these things here. They're radials, obviously, and not axials. But I went to go and look at getting the right parts for this. These caps are $44 each. This cap, which is the radial equivalent, $3. So, I'm guessing this cap's going to get a wire added to it. I mean, it's almost a shame to replace these, but I'm suspicious that it might be leaking. There's like some marks just here. I'm not quite sure if these are any good. They kind of tested okay, but can't trust them. These are really old caps. They only last so long before the seals start to fail, then they start to leak. If it leaks, it damages the circuit board, destroys the unit, or potentially causes a lot of problems with it. So, I'd rather just replace them. At least then I know they're good for at least another 10 years, instead of potentially failing next month. Now, I don't normally like to do what I'm going to do with this. I always like to put the correct type of cap in. You know, if it's an axial cap, I'll put an axial cap in. I don't like to do what I'm just about to do, which is to put a radial cap in. But for 10 times the price, I mean the size is also significantly different. I'm not happy about it, but I don't want to leave these ones in there. And I don't want to spend $90 on 2 capacitors. That's just stupid. So I've taken the first 2 caps off. I've got this cap off. This was a hard one to get off because it's glued down at the same time. See the silicone under here, so that's made it challenging to remove. So that was fun. Anyway, I've got to scrape the silicone off and I can fit the new one in. Once I clean that off, clean those holes out, now I can fit the new one, which unfortunately doesn't have the right lead spacing. Because these older caps are much physically bigger, the lead spacings aren't quite matching, like these ones here either didn't also match, they're a bit narrower. If you know exactly what the lead spacings are before you pull something apart, you can order the right ones and get the right lead spacings in some cases. But in this case, I don't, so I've got to make do. They will fit in one way or another. Solder this one in. This has got some pretty thick legs on it, and there's quite a big thermal plane here as well. So, yeah. Now, when you're bending these legs on these capacitors, you have to be really careful because you can actually damage the seals and bottom caps. So when you're bending them, try and do it in a way which you're not putting stress on the seal at the bottom of the capacitor. It's quite important. I mean, otherwise you can end up with the capacitor which won't last very long because you've damaged the seal and it will start leaking or vent more easily or something, you know. Try to make sure it's flowed through to both sides properly. Big thermal mass. That's that one. I'll start with this one here. And what I'll do is I'll take it out, then I'll measure it out circuit with my capacitance tester and I'll see how they actually measure as well, just out of curiosity. Now this sort of cap, you can often pull them out from the top side, which is quite convenient. Now, negatives that end. Don't forget negatives that end on this capacitor. Goes like that. Let's test it. So got my tester set up over here. Unfortunately, these LCDs are really hard to see. It's just the way they are. I don't know if I can get anything like extra better lighting on it. ESR. There we go. 1.26 ohms. It reckons it's bad. Value 248. That's not bad value. Leakage. I think it's good leakage, but the ESR I thought was bad. So let's try one of the brand new caps, exactly the same specs, well at least the same voltage and capacity. So now I'm testing one of these. ESR 0.02 ohms, significantly better ESR. 345, capacitance is equivalent. Leakage. Yeah, going to microamps. Yeah, no worries at all. So these new caps are definitely better. And whilst I've got the tester going, who wants to test these other ones pulled out? It's a 35 volt 1000 microfarad. Let's see what it thinks of this one. Good ESR, good value. Bad leakage. So that one was bad. Let's check the other one. ESR is good. Value is good. Very different leakage. Still a milliamps though. Still says bad. So yeah, both of these 1000 microfarad 35 volt caps, these things are both bad. So they're being replaced. Well, I have replaced them. So excellent. And then I've got one more, which is this 25 volt 10,000. Well, it's a bit more than that, but we'll put it in there. 25 volt. This is rated at 11,600 microfarad. Got it right, am I? Yep. This one which had the silicon holding it down, this thing. ESR. Excellent. Value. Pretty good. Certainly within region. Leakage. Might take a little while to actually try it because it's a big cap. It says bad. It says bad for leakage as well. No, bad for leakage. So that cap there is also bad, apparently. So, excellent. So I've replaced the caps in this now. These are glued down. I've glued these down. I've glued that down just to help stabilise it, seeing as the lead spacings don't match perfectly. I've also replaced the 2 caps on this board as well, the 2 remaining ones. I did all the small ones already. Did those 2 there, which are 350 volt 4.7 microfarad. I've got it here hooked up ready to test. Let's actually see what it does on the meter here. Right, let's check ESR first. Reckons it's good, 7.7 ohms, because it is high voltage, don't forget. Value 3.4, that's low by quite a bit. It's 4.7, so that's significantly lower. And leakage, it's fairly high in the milliamps. Yep, says it's bad. So it thinks that cap is bad. Give it a chance to discharge. Before I zap myself. Let's check the other one. Same deal. ESR 6.8. It's slightly higher than the other one, wasn't it? Value 3.56. Again, it's down. Leakage 11 milliamps, 8 milliamps. This is as high as the other one, isn't it? It's coming down quicker though, but also bad. So yeah, quite a few bad caps in this thing.
One eternity later.
I'm back on this thing. I've waited another week. Fans have just arrived. I just recorded some footage for the mailbag for that, so you'll see that in the mailbag. Also demonstrate the comparison of noise between the original one and these two. These two are basically silent. This thin one here is very slightly quieter. I was actually very tempted to use this one, but this one is pretty good. So I'm going to go with the same dimensions as the original. I think the airflows on these were, if not slightly more than this one. Not much. I think it was like 19 CFM or something, and this was like 23 or something like that, I think it was. Don't know exactly. But there was slightly more. Wasn't much in it. I think this one might have been slightly less. That might have been 15 or 17 or something. I can't remember. Let's put these things on here. So I've been waiting to put this thing back together, but I couldn't do that until I got the fan turn up. So also I don't need to wipe my gloves just now until I start handling that board. I'll be using gloves when I do that bit. This needs to mount on here. Now it's got to suck air in, out, in, that way. Sucks air in through that way because of the filtering. So I'm going to actually shove it sideways like this because I've got this massive long wire on here. And I'm going to shove that in there. Onto those studs, hopefully. Just gets in. Right. Now what's about rubber mounting this thing? And I could put some rubber gaskets on there or a little bit of shim. I'm tempted to. It's probably going to be okay though. I mean, I could rubber mount, put some thin foam around something behind there just to protect it slightly. I'm tempted to, but it's probably fine. I mean, it's still way quieter than the original fan, so yeah, I might just do that. I might just leave it as it is. Anyway, I'll put this bit back together and I'll come back. Right, it says bottom casing. As you know, I've replaced all the electrolytic caps on all the boards, so it's fully recapped, at least as far as electrolytics go. I haven't bothered doing any other kinds of caps, just those ones. So there's the bottom board that's got to go in, but we kind of got to put this in conjunction with the rear panel. So you've got to try and do both things at once because it kind of latches together and sits in there together. Right, so those got to go through those holes. See the fuse holder and a AC mount is going there. This has to all kind of slide forward. Got to get the power switch through the front. That goes in behind there. There we go. That's that board there. Kind of back in again. I've got to try and get it back in position properly. I've got to try and go over these little standoffs that are in here. These posts, there we go. They're quite tight. Quite a tight fit. I think that's all down. Yep, that's all in. So this wire I've still got to do obviously before I power it up again. Got an earth tab here which I need to attach to this. Threaded stud here. This tab has got to go back onto there. So earth the back panel. So it's got a dedicated earth wire, which is nice. How things should be done. Now I've got this earth link here. That's partly because of one of these other panels has got a link on it. So the GPIB connector here, it's got an earth tab which has to go onto this post. So that one I'll have to do afterwards. But for now, let's get this in. So I think I'm going to screw that board down as much as I can. This wire obviously goes to the daughter board, it goes at the top, mezzanine. This plugs down here, so we can do that. gets it out of the way. We'll plug this board into there. If you worry about how much it's flexing, it's just, you know, so that's there. Okay. All these plastic posts, these are standoff posts which will hold the mezzanine board up. So those will go there, like that. That'll sit like that. So that's all the mezzanine ones, that's right. These other little screws or spacers which go in the bottom here. Onto these two rear ones. Okay, and they'll go in there. It's always the challenge is trying to be where all the screws go. So you've got the four long ones here, which will go through the mezzanine. The long screws go through this cover to hold that mezzanine down like that, right? And there's another screw around there somewhere for this, for that bracket, once that's plugged back in again. These two here will be the ones which go into the bottom. Pretty sure. Let's find out. Two. Right. So I've then got these. These are for the GPIB connector, which I'll sort out afterwards. I've got these ones here on the back. I'll shove these ones in because they can go in. Gets rid of those. Maybe. There we go. There's two of these in the back. Took a while to get it in there. Let's go in. Right. Not tight yet though. Got the ones in the front. There's a screw down here behind the transformer. So that'll be this one here. Bet it's that one. So I've taken the shield off. Now I don't have gloves on, but I'm being bloody careful what I'm doing here. I'm trying not to touch anything. So we've got the cable here, which is the input. We've got this other shield. Let's get this out of the way for the time being. So we've got the center conductor, which has to go onto that pin there. Then the blue wire, which goes to that side, black wire goes to that side, and the white wire, which goes to that one over there. Alright, so I'm going to just push all these in and hope for the best. Okay, so I'm going to start with the center conductor. I'm hoping that without me actually using my fingers, I don't have to worry about potential contamination. That one goes there. That one goes there. Then this one will go there. Okay, now we've got this strap here to hold the thing down. Which I believe is this screw. It better be. If it's not, I've got something wrong. There we go, that works. So let's just push this through a little bit, just to make sure it's definitely pushing on the connectors and not pulling on them. Right, so that's together. Put the shield here back on again. However that fits, it fits a certain way. It's got some little posts it sits on. There we go. That sits on there. Now we've got this shield. Okay. Just making sure it's aligned correctly. Should be a little hole that goes into just there. Now we've got to get this connector here on. Do not get it off by one pin or anything. Could easily get that wrong if you're not careful. Right. Let me put this shield over the top. which has got these long screws that go through it into the bottom of the casing. Obviously, the moment of truth is going to be, does it work when I go to power the thing up? After all the recapping and everything I've done to it. I'll do these up fairly firmly, but not too much, because of the fact that there's metal threaded inserts into plastic. You just need to make sure they're going to come loose. Right, that's that part. So now what I need to do is the fan wiring, get that connector swapped over so I can plug that in. Once I've done that, then I can reinstall the GPIB board, run that flex down, plug it into the board down there, and then we can try it out. Well, but I don't really want to do, because I was kind of hoping I could maybe one day try and put new bearings in this fan instead of wasting it. But I need to cut this connector off so I can use it. Now what I'm actually going to do here is stagger the connections so they're not directly next to each other. Just reduce the chance of a short circuit if the heat shrink or something wears through. If I stagger them, there's less chance of something going wrong. As I cut the wires off short, I've got the heat shrink on the wires already. Never forget the heat shrink. One day you will, and you go, oh damn it, and you've got to start over again. We've all done that. So, it's all prepared, all tinned, fresh solder already on everything. All I'll do is put the wires together now. Joining in, side to side is not necessarily the best way of doing it. Sometimes it's best to twist them together and sort of stuff. I've had no problems with this. I mean, it can be a bit fiddly getting it right, but generally speaking, I don't really have any problems with it. So let's just attach the wires and try not to do this for too long, so I don't want to have the heat shrink changing size on me before I'm actually ready. Side. Let's have a close look, make sure it look okay. Yeah, look fine to me. Let's slide the heat shrink up. Okay. So we'll try and I'm going to double insulate it, so I've got the original layer and I've got the thicker one. I'm just going to go over the top of that as well. Okay. Let that cool down before I slide the other one on. Is that done? Happy with that for that. Just plug that in. GPIB board. What is it? That's probably more of an IA board than anything else. It does IO as well, not GPIB. So I've got a screw for that. I'm not going to tighten it up yet because I've got to get the back all lined properly. Just mustn't forget to come back and tighten it up. Haven't got the mounts here for the GPIB, which have got these nuts with spring washers on, spring lock washer things. So stick that through there and try and put these on without dropping the bits inside it. That's always what the bit's going to go wrong, isn't it? That's going, yep, okay. Next one. Come on, go in there. Of course it's going to be awkward. What it is a a screw to the circuit board which is interfering with the nut placement. And I'll just drop that washer inside the circuit board. Hope it comes out. There it is. That's lucky. I'll come back when I've got this in, because this could be tedious. Well, this one was definitely being a pain. I got it on, I was tightening it, I just about to stop turning it, and the stud broke off it. Not very strong, that one, it seems. So, got the one less stud on there. Shouldn't really matter. I mean, I've got GPIB anyway. I mean, I could put a bolt or something through it. I mean, I think it's fine. It's not going to go anywhere. But it's just disappointing that that's happened. I'll have to see if I've got anything else I can use to put in there. Maybe. I'm going to have to see if I can find a replacement piece for this. I don't have anything around. The ones I've got are like massively too long. There's no threaded bit that needs to have it threaded. So I'll have to see if I can sort something out for that. I have to source a suitable piece. I don't know if it's the same thread as you would find on like a graphics card or something like that. You know, these old computer cards or something like that. PCI card or something. I don't know if it's be the same. Maybe it would be. I don't know. I have to look. So now I've got to put this connector back on, which goes down to here, which is a bit awkward to reach. Anyway, I'll put the earth on there. That's attached. So once I've got this connector on down here, we can try powering it up and see if it still works. Well, I'm going to power this up without the cover on in case there's any magic smoke. You never know. Switch is out. That's at least it was working properly now. Right. Turn the switch on. B5, yep, cool. Recognise the GPIB bus as well, so that's looking normal so far. 27 watts. Fan's not too bad. Well, obviously I can hear it, but it's way better than the original one was. Well, so far it's looking fine. It's got these two little round bridge rectifiers here. W01s or W02, something like that, whatever they are. This style and this size I don't trust because I've seen these blowing. Lots of equipment I've seen them failing, so I don't trust those. So I just like to just have a bit of a feel and make sure they feel okay. Okay, well it's looking promising. That's good. No smoke, so I think I'll put the top cover back on. And we can have a pop play with it. Right, I've got it hooked up to a Triax cable. I'm going to show you the multimeter shortly. We'll have a play with it together first, and we'll see what happens. Filter material touching the fan, so I pulled it out a little bit. Okay, because I shoved it all in. Source, we want to do voltage limit, let's do 10 volts. And amps, let's do 100. Enter. Exponent 3 should give us 100 milliamps. Okay. I'll turn the output on. If I get good connection on the back here, this cable's giving me trouble. I'm worried about the socket on the back. Yeah, the socket on the back's giving me trouble. Amps, let's do 10. Enter. Let's go 10 milliamps instead. Yeah, because it was slightly bent. Okay, now we've got something. It's out of whack a little bit, but don't forget I've only just turned everything on, so it's all warming up. I'll show the multimeter. So I'm starting to think that I might need to replace that connector on the back. See if that these cables aren't particularly wonderful. I had problems with this before when I was first testing it, so it could be a bad connector. Anyway, I'm doing 10 milliamps, so you can see we're getting something there. Let's do 1 milliamp. Yeah, okay. Let's do with the exponent of 6. 1 microamp. Yeah, it's doing that. Okay. 10 microamps. Yep. Exponent of 9. So 100. Yep. So it is at least doing the currents. It isn't looking accurate, but then I don't actually know for sure if this meter here is also accurate because I've only just got this thing. And they're both warming up. Obviously, really should leave this things to run for like an hour and a half, 2 hours, maybe a bit longer. Let them warm up and stabilise. Because right now we don't actually know if we're in a curve or not to be anywhere near right. Let's do 1. Here we go. Yeah, cool. So let's do 0.1. Yeah, 0.01. Yeah, it's kind of there. Let's do 0. Here we go. So there's the 0 point there, 0 offset. I should be able to null that out. Ish. It's in the noise. Yeah, ish. Okay. Let's go to 0.01 again. It's there right now. It just slows down so you can see it better, right? So let's do 100. So 0.01. It is there. Yeah, this is right down the noise though. 1. This filter's not the one I want to use either. It hasn't saved the filter I want. I really need to figure out the user thing so it'll save the filter I want by default. Anyway, it's working, so that's something. Yeah, I'm not trusting this cable at all. That measurement's looking pretty good though. 1, enter, should be 1. Yeah, it's not too bad. 10. Yeah. So 100 microamps I'm on. Get it right. Okay, and exponent 3. 100 milliamps. Yeah, that's quite a way out on the top end there. I expect that to be a lot closer than that. Yeah. Anyway, it's working. But I think I need to revisit this Triax connector. I'm not happy with it.